Hi everyone, let's take a look at the following example. Given the following triangle, give a single vector that is equivalent to the following vector expressions. Now, I'm hoping you can open your mind and try each part with a dual mindset. Solve it algebraically, confirm it graphically, and if you do it that way, you will maximize your outcome. Now, in part A, we're looking at vector AB plus vector BC, which equals to vector AC. Again, because these are the same, you basically look at the first and the last part. So this is the reason why the answer is going to be vector AC. Now, graphically, if you think about vector AB, you start from A and you point to B. Vector BC, you're going to start from B, point to C. And if you apply the triangle law, again, you start from the base or from the tail, pointing to the head, and this will give you vector AC, just like that. So again, a dual mindset. Part B, if you think about vector BA minus vector CA, this equals to vector BA plus vector AC, which equals to vector BC. Again, if you want to confirm this graphically, vector BA looks like that. Vector negative CA, which is the same as vector AC, looks like that. And if you apply the triangle law, the final answer is going to be vector BC. Part C, vector AB plus vector BC plus vector CA plus vector AB. Now, by inspection, my educated guess is the final answer works out to be vector AB, but let's find out. Again, if I think about the first pair, this equals to vector AC. Why is that? Again, these are the same. So I look at the first and the last, and I can collapse them as vector AC. Likewise, if I think about the second pair, vector CA plus vector AB equals to vector CB. Again, I know this because these are the same. I look at the first, I look at the last, and I combine them, and that's going to be vector CB. Last but not least, if I look at vector AC plus vector CB, the final answer is going to be vector AB. Again, confirm this graphically. Look at vector AB. You start from A and you point to B. Look at vector BC, just like that. And when I add them, this would give me vector AC as expected. Now, I'm going to hop over to the second pair and then combine them at the end. So again, if I look at CA plus AB, that's going to be CA plus AB. And that equals to vector CB as expected. Again, vector CB. Now, I'm going to go back to the first pair and the second pair and confirm this graphically. So AC looks like that. CB looks like that. And of course, the resultant vector equals to, let's try again, the resultant vector using the triangle law equals to vector AB as expected. Now, before we continue, I would like you to press pause. Try D, E, and F. When you press play again, I'll be here. Part D, negative vector BC minus vector CA. Now, if you look at this algebraically, this equals to positive vector CB. And if you look at negative vector CA, that's positive vector AC. Now notice I purposely wrote this in a different sequence because I'm applying the same concept. So algebraically, this equals to vector AB. Now to confirm this, again, we go back to the graph. Negative vector BC is the same as positive vector CB. Negative vector CA is the same as positive vector AC. And again, as expected, when I combine this is going to be vector, this is going to be vector AB, just like that. Again, we're applying the triangle law. Let's keep going. We are making progress. Part E, negative vector CB plus vector CA minus vector BC. So this equals to, again, if I think about negative vector CB, that is the same as positive vector BC, which I'm going to put in the middle. Vector CA, I'm going to copy as is, which I'm going to put at the end. And if I look at negative vector BC, that is the same as positive vector CB. So again, I know this because I'm kind of thinking about it mentally before I'm writing it down on the whiteboard. And again, algebraically, if you want to go super fast, you can tell this equals to vector CA. But just in case you're not connected yet, vector CB plus vector BC, these are opposite vectors, will add up to be a zero vector plus vector CA, and of course, that's going to be vector CA. Now, to double check your work, let's redo this graphically. Again, if I think about negative vector CB, this means it's going to be positive vector BC, which looks like that. Vector CA is going to look like that. So again, by applying the triangle law, this equals to vector BA. Now, if I'm subtracting vector BC, that's the same as positive CB. And of course, again, CB plus BA, this will give you CA as the resultant vector. So again, that dual mindset will maximize your outcome. Part F. Let's draw a line here to separate those two parts. Vector AC plus vector CA plus vector AC plus vector CB. Again, by inspection, I am thinking, my educated guess is the answer is going to be vector AB. Now, let's start the first part. If I think about vector AC plus vector CA, that's essentially a zero vector. But if you want to show some steps, you can write down vector AA. Again, we know that because these are the same, C and C. So I copy the first and last, which are basically vector AA. Now, the reason why this is a zero vector, by the way, is because if you start and stop at the same location, essentially that's a zero vector. Now, likewise, if I look at the second pair, vector AC plus vector CB, this equals to vector AB. Again, these are the same. I look at the first and last, and I combine them. And of course, a zero vector plus vector AB is going to be vector AB. Now, let's redo part F by looking at the graph. AC looks like that. CA looks like that. And if you add opposite vectors, by definition, that's going to be a zero vector. If you look at vector AC plus vector CB, again, using the triangle law, this will give you vector AB as expected. I hope this makes sense.